Hey, good morning, everyone. Today we're looking at the Algebra Day 10 work. So this first section here, 8-1, we're looking at problem 2 and asking, is this a growth or decay model? So 24 times 0.8 to the x, is if this base is smaller than 1, if it's a fraction between 0 and 1, then it's going to decay again. This would be like 1 minus r, so where that r would be 0.2 or 20%. So we're losing 20% per marking period on this decay function. Problem 8 just wants us to graph this exponential function, just kind of practicing that again. So our initial amount here is 1/2 because 3 to the 0 is 1 times 1/2, y equals 1/2. So there's that point there. And then when x is 1, this is 3, but then half that is 0.5, 1.5, and then it keep going from there. Horizontal asymptote is still y equals 0. It's going to snug you up. So it's going to keep going up, right and up. It's going to look like the 3 to the x function, only all of those values are going to be half of what it is. So instead of going through 1, 3, 9, it's going to go through 0.5, 1.5, 4.5, things like that. Okay, so 11, we got some bear population here, and we have we're increasing at a rate of 2% per year. Okay, so and it says we have 1,573 bears this year. So that's my starting amount, and I'm going to write 1 plus r. That's my I'm going to grow at 2% per year. So then here's my model, 1573 times 1.02 to the x. So just plugging in 10 into this function here, I get 1917 bears. 8-2, dealing with some more compound continuously problems. So in this number 6, PERT again, we're going to start with our principal of 20,000, and then times e raised to the 3.75% is 0.0375, and then for 2 years. So plugging all that into the calculator, I get 21,557 and 68 cents. So for 17, I have two transformations to 2 to the x. Again, so 2 to the x is the exponential growth, 0, 1, 1, 2, 2, 4. I'm going to shift that to the left, those points to the left, 1, and then reflect over the x-axis. Y is equal to the negative of what it was. If you change the sign on all the y values, you're going to reflect over the x-axis. So if I plug in -1 now, -1 for x, I get 2 to the 0, which is 1. Change that sign, -1. If I put in a 0 now, this is 2 to the 1, which is 2, and then change that sign to -2. So I have this. It's going to keep growing, only going down as you go to the right. Okay, so here's our log game we're playing here. So what exponent turn a 2 into an 8? So this, again, means the same as this. 2 to the, log base 2, 8 equals something. Log base 2, 8 equals, huh? So then 2 to the, huh, is equal to 8. And that has to be a 3. So again, this is the log form. This is the exponential form of two things saying the same thing. What exponent turns a 2 into 1/2? This is asking 2 to the what equals 1/2? Well, that's got to be -1 in order to flip the 2. 2 to the -1 is equal to 1 over 2 to the 1. What exponent turns a 5 into a 125? 5 to the what equals 125? That's 5 cubed. 3 to the what equals 1? So, 3 to the what? Yeah, 3 to the what equals 1? That's 3 to the 0 equals 1. So the answer is 0. Okay, so here's some more of these log rules here. I'm going to condense on the first one and then expand on the second one. Again, these new rules that only apply to logs and exponentials. So all the old school algebra still applies. Now you can just do some of this new stuff if you want. So one of the rules is you can bring this 2 up. Log x squared is the same as 2 log x. I can bring this 3 up. Log y cubed is the same as 3 log y. So now I have log of something minus log of something. So when they're subtracting on the outside is the same as dividing inside. So I condense this down into 1 log, this right here. Okay, so this here, I have all the stuff on the inside in 33, and I want to expand it out. So the first thing I'm going to do is I have something divided by something. So I can do that as subtraction on the outside, log base 2x minus log base 2yc. And then for this, I can expand this out because it's two things multiplied together, so I can add them. And just be careful, remember, like it's minus this whole thing, so I'm going to minus all of this, which is minus minus. So even though like this is a plus here, you still like using old school algebra, I got to distribute this -1 across that entire thing. So there's my full expansion there. 8-5, now we're solving some equations. I'm going to solve this equation here, this exponential equation. Well, my variable's in an exponent. I'm going to rewrite this in log form because the log is equal to the exponent. The log is equal to the exponent. So the base goes here, log base 4, 3 equals the exponent. Log is equal to the exponent, n minus 2. So if I just add the 2 to both sides, do some old school algebra, n is equal to log base 4, 3 plus 2, which on a calculator is finished to this. So this one here, I have my variable trapped inside a log, so I'm going to rewrite it in exponential form. Don't forget log is log base 10, so this is 10 cubed is equal to 3x minus 2. So I'm going to add 2, divide by 3. 10 cubed is 1,000, plus 2 divided by 3 is 334. Okay, so 2 more solving. Now this just has to do with base e here. So first move here is I want to get this base all by itself, this exponential thing all by itself. So I'm going to divide both sides by 4 to get e to the x equals 5/2. Now I'm going to rewrite the form. I'm going to rewrite this in log form because the log is equal to the exponent, and that's where my variable is. So I'm going to do log base, and then log base e, I'm going to rewrite that as natural log. Log base e of 5/2 is equal to the exponent, is equal to the x. And if you want, you can just finish that on your calculator. That's 0.92. For 24, first thing I'm going to do is I'm going to divide both sides by that 2, and I have this here. Now I have my variable trapped inside a log, so I'm going to rewrite this in exponential form. So e to the 7/2, base e, natural log is log base e to the 7/2 equals 3x minus 4. Add 4, divide by 3. This is the exact answer here. And if you just want to, you can finish it up on your calculator to get this here. So hopefully you had fun on this Algebra Day 10 problems. See you in class.